The circus, Academia Maria Miajarel, is an institution that's about 120 days old. First of all, our idea was to adopt a civic approach. Animals being forbidden from being used in circuses, we decided to replace them with animals.
This show we decided to highlight 4 specific features. Our sloth robot Pablo is a robot on which we wanted to work on movement. We wanted a robot capable of moving on a rope. But how could we reproduce the movement of this animal's large legs with simple motors? By searching the internet, we found the connecting rod and crank system used by climbing robots. It wasn't enough to reproduce a similar system, which we found on Cult 3D and that we printed using the class 3D printer. We chose ABS as the material because it is a zero-emission, biodegradable plastic. We had to work on balance because the sloth kept falling off the wire. After a number of trials that required us to work on the robot's balance, we managed to produce a quality movement.
That's why we wanted him to move forward only when rewarded. This allowed us to work on another feature, color detection, and make our sloth more alive. The color sensor emits light that reflects off a surface. Then the reflected light is measured and compared with pre-recorded colors.
The second feature that we wanted to highlight is the use of ultrasonic sensor, which we exploited to their full potential with the dancing robot based on CHEMIO, which contains 7 ultrasonic sensors. The aim for the robot was to be able to obey us with its finger, its eye and eyebrow, and all its hand, and sometimes even its hammer. It works in a simple way. An ultrasonic sensor is capable of emitting 8 frequency sound. This sound propagates, bounces off an obstacle and returns in the form of an echo. All the sensor has to do is cover the round shape time into distance.
3 meters!
Given the speed of sound in the air, each CHEMIO sensor 3-4 makes a different movement, programmed and the Blocky for CHEMIO website.
The third feature we decided to exploit is demonstrated by our clown. Because what would a circus be without a clown? This component is capable of measuring the orientation of gravity in relation to the robot. We would like to thank ChatGPT for its invaluable help. The robot moves forward when it leans backward, and backwards when it leans forward. It turns when it leans sideways. The main problem was the weight of our clown. Initially we had a cyclist, built entirely from Lego, but the weight made the robot very unbalanced, so we opted for a 3D printed clown, then for a half clown, to lighten the weight and recenter the center of gravity. Poor clown.
Finally, we chose to use AI, and more specifically image recognition, as our fourth feature. Using McQueen equipped with Escalant's camera, we were able to program our 2 little monkeys to react differently depending on the presented face. Caution. The program code is relatively simple. The camera can record several different faces by giving them the name 81, 82, etc. In the world of artificial intelligence, we call this supervised learning. All we had to do was program our little monkeys to react differently depending on the ID they recognized. The option of facial recognition of several faces enabled us to complete the project on humanism or little monkeys.
To open the curtain automatically, we built together a wire winding system with 2 motors and a cyberpry card to add a sound sensor. The curtain only had to open when the audience applauds. Finally, we obviously wanted our circus to include an animal parade. On the day of the show, the animals know that they better do what I tell them or their battery will be confiscated.
Here we go! Our show has been entirely finished and functional. The artists are just waiting for the audience, so...
Have fun watching the great show! Academia Maria Miajarel!